Good day, students. You are welcome to Makyem tutorials. Today we are going to solve 5 UTME physics questions on simple machines. These are the questions that JAMB likes repeating, and I want to assure you, because I've checked around all the JAMB questions from different years, and I found out that there is no how you won't find questions on simple machine in your JAMB physics, UTME physics. So it is a topic that they like to patronize. So today, if you listen carefully and if you get the concept of what I'm going to teach you, you won't have problem with machines. So let's just start with the first question. An electric heater pump rated 1.5 kilowatts lifts 200 grams of water through a vertical height of 6 meters in 10 seconds. What is the efficiency of the pump? Let's look at the parameters that we were given. The power of the heater is 1.5 kilowatts. Is to lift water, which is the load. Load is 200 kilograms. The height is 6 meters and the time is 10 seconds. Let's look at this. Power 1.5 kilowatts. We are going to convert the kilowatts to watts, and that will give us 1.5 times 1000, which is equal to 1500 watts. We're giving G2 to be 10 meters per second squared. The load is 200 kg. Now we are to calculate the efficiency of the pump. Now the formula for efficiency is work output divided by work input times 100. And remember, work output is the work done by load. Work input is the work done by effort. So the work done by load, since work done is defined as the product of force and distance, so work done by load is load multiplied by the distance moved by load, while the work done by effort is effort times distance moved by effort. That's effort multiplied by distance moved by effort. We all know that because we're given power. Power is work done divided by time. So instead of writing efficiency this way, I can decide to say efficiency is equal to power output divided by power input times 100. What is the power output and what is the power input? The power input is the power of the machine or of the pump itself. Now the power output is the power of the load. So that means we have efficiency is equal to power output. Okay, let's get the power output first. Power output is equal to, power is work divided by time. So it's work done by load, work by load divided by time. Work done by load, let's look at what we're giving. Work is force times distance. Now we're giving load to be 200 kilograms. If you want to convert it to force, which is like weight, you multiply it by this acceleration due to gravity. So when we multiply it by 10, it becomes 2000 newtons. That is the load. Now work done, this is the force now, is 2000 newtons, that's force, times distance is 6, divided by time, 10 seconds. Look at it. This gives us 1,200. This 1,200 is the power output. So let's go back to our definition of efficiency. Efficiency is power output, that's 1,200 divided by the power input is this one. Power input, that's the power of the pump. 1,500 times 100. Let's do our division. We have 1, 2, 0, 0, 0, 0 divided by 1,500. This. So we have 1,200 divided by 15. And what is the answer? Divided by 15. So it is 8. It's going to be 80. Yes, it's going to be 80. So the answer is 80%. This is the efficiency of the pump. Power output divided by power input times 100. That's the first question. Now let's go to the second question. In a wheel and axle mechanism, the diameter of the wheel and axle are 40 centimeters and 8 centimeters respectively, meaning the diameter of the wheel is equal to 40 centimeters. Diameter of axle is 8 centimeters. Given that the machine is 80% efficient, efficiency of the machine is 80%. What effort is required to lift a load of 100 newtons? What effort is required? We don't know the effort, but the load is 100 newtons. If you want to solve a question like this, there are some things you look at. One, you are given the diameter of the wheel, you are given the diameter of the axle. So this is a question under wheel and axle in machines, simple machines. Now for a wheel and axle, the velocity ratio is equal to the radius of wheel, which we write as big R, divided by the radius of axle, which is small r. We have been given the diameter of the wheel and the diameter of the axle. Diameter is 2 times radius. So if we can say the velocity ratio, since diameter is 2 times radius, that means radius is diameter divided by 2. Since you are dividing this by 2, you are dividing this by 2, we don't need to do the division again. All we need to say is the diameter of wheel divided by the diameter of axle to get the velocity ratio. So VR is equal to 40 divided by 8, which is 5. Velocity ratio does not have any units. Please, I want you to write this, all the questions that I'm going to solve. Get your paper or your book and get a pen and write so that you can go over and read this again. You can even call your friends that are around you, or if you don't have any friends around you, you can share this video with them and then let them watch. And if you love what I'm doing on this channel, I will advise you to subscribe to this channel so that YouTube will notify you anytime I post another video. And then please just click on the bell notification icon so that you'll be notified quickly whenever I post videos. I promise you I'm going to post interesting videos, JAMB, UTME, WAEC, NECO, and all sorts of national exams. Thank you. Let's continue. The velocity ratio is 5, and we're doing the efficiency. Remember, efficiency is mechanical advantage divided by velocity ratio times 100. Now, you were given the efficiency as 80. You don't know the mechanical advantage. But you know the velocity ratio. So the only thing you don't know here is the mechanical advantage. And remember, mechanical advantage is load divided by effort. Check. Do we have load or do we have effort there? We want to calculate the effort, but we have the load. So we are on the right track. Let's just do some substitutions for this formula here. So efficiency is 80 here is equal to MA divided by VR. We got it to be 5 times 100. If we cross multiply, we have 80 times 5, which is 400, is equal to 100 times MA. It means mechanical advantage is equal to 400 over 100, which is 4. Remember, mechanical advantage is load over effort. So we say mechanical advantage is load divided by effort. What does this mean? It means our mechanical advantage, which is 4 is equal to, do we have any load? Yes. 100 divided by efforts. Let me divide it here. So 4 times, that's multiplied by effort, is equal to 100. Effort is 100 divided by 4. Effort is 25. Effort is a force, so it is 25 newtons. It is this simple as that. That is the second question on machines. Are you finding it interesting? Are you enjoying the class? Please don't forget to subscribe to this channel, and then we continue with the third question. The diagram above, this is the diagram here, represents a frictionless pulley system with a weight W in equilibrium with another weight of 40 newtons. Find the value of W. Now, this is a very simple question. The question says that this pulley, this is a system of pulley, that this pulley is frictionless. Whenever a machine is frictionless, it means there is no friction acting on it. That means the efficiency of the machine is 100%. There is this question in physics, SSE, UTME, they will always ask, why is the efficiency of a machine not equal to 100%? Or why is it not possible for a machine to be 100% efficient? It is because work has to be done against friction. Part of the work done by the effort is used to overcome friction. But in this case, the question says it is frictionless. That means the efficiency is equal to 100%. Let's look at efficiency. Efficiency is mechanical advantage over velocity ratio times 100. If the efficiency is to be 100%, it means MA must be equal to VR. Do you get it? For instance, if MA is 5, VR is 5, 5 divided by 5 will be 1 times 100 is 100%. So for the efficiency to be 100%, this place must be 1. That means mechanical advantage and velocity ratio must be the same. So MA is equal to VR. Now there are two pulleys here. When you have a system of pulleys that we call block and tackle, when you have 2 or more pulleys joined together to lift a load, the velocity ratio of the system of pulleys is equal to the number of pulleys in that system. In this case, we have 2 pulleys. This means that our mechanical advantage is 2 and our velocity ratio is 2. Remember, because the pulleys are 2, the velocity ratio is 2. If we have 4 pulleys, the velocity ratio will be 4. If we have 6 pulleys, the velocity ratio will be 6. So let's now start. It is frictionless. So how do we calculate? When we're given the efficiency, let me check the question. Okay, find the value of W. We're not given the efficiency. So let's look at it. Now, if you look at this system, you will see that this one is acting downward. The way the pulley is fixed, you know this is the one lifting this one. So it means this is the effort and this is the load. So the effort is W, the load is 40. If our mechanical advantage is load divided by effort, mechanical advantage is 2, load is 40, effort is E, because we are asked to calculate the value of W. Now I said effort is equal to W, so we change this one to the W. Cross multiplying, we have 2W equals 40. W equals 40 divided by 2, which is 20 newtons. That is it, quite easily done. So let's go to the next question. Question 4. If a heavy barrel is rolled up an inclined plane, inclined at 30 degrees to the horizontal, what is the velocity ratio? You don't even need to think too much here. The plane is inclined at 30 degrees. You are rolling a load up. The velocity ratio of an inclined plane, inclined at an angle theta, is equal to 1 divided by sine theta. The theta in this case is 30. So velocity ratio is equal to 1 divided by sine 30. Sine 30 is 0.5. So 1 divided by 0.5. The velocity ratio is equal to 2. It's as simple as that. If you are writing UTME and you see a question like this, you don't need to solve. As in within 10 seconds, you don't need to waste your time. Just say 1 divided by 0.5 and that becomes 2. How did I get 1 divided by 0.5 as 2? It's 1 divided by 0.5 is 1 over 2. So it becomes 1 times 2 over 1, which is equal to 2. So we go to the next question, which is question 5. Like I said when I started this video, I am going to solve 5 questions across all years. And I'm going to make sure that I touch the topics under machines. We've done inclined plane, we've done wheel and axle, we've done general machines. This one now we are going to do block and tackle. So let's look at the next question. I'll clean this. Okay. The diagram I'm going to draw now is a block and tackle system of pulleys. Okay. Pulley 1, pulley 2, pulley 3. We have a hook here. We have another pulley, pulley 1, pulley 2, pulley 3, and we have something like this, and a hook to a load of 240 newtons. This one comes like this, and then we have 1, 2, sorry, 3. So 80 newtons. Yes, this is the diagram. The diagram above is a block and tackle of a system of pulleys in which the effort of 80 newtons is used to lift a load of 240 newtons. What is the efficiency of the machine? This is a very cheap question. Effort 80 newtons, load 240 newtons. What is the efficiency? We want to calculate the efficiency. This is a block and tackle. I said it earlier. Look at the diagram properly. We have 1, 2, 3, 4, 5, 6 pulleys. So what is the velocity ratio of this system of pulleys? Quickly type it in the comment section. Let me wait for like 5 seconds. 1, 2, 3, 4, 5. The velocity ratio is 6 because we have 6 pulleys. 6 pulleys. So the velocity ratio is 6. Remember, efficiency is equal to mechanical advantage over velocity ratio times 100. What is our mechanical advantage here? It is load divided by effort. What's our load? 240. Effort 80. 240 divided by 80 gives us 3. MA has no unit. So we're now saying efficiency is equal to mechanical advantage over velocity ratio times 100. This gives us 1 over 2. That's 1 divided by 2. 1 divided by 2 times 100. The efficiency is 50%. Yes, we've solved 5 questions across the topics under machines in UTME Physics. So I wanted to go over this again, rewatch the video so many times so that you understand this concept. But I am assuring you, if you can solve all these questions, you won't have problems in simple machines. If there is any topic that is giving you problems and you want me to solve UTME questions on those topics, or you want me to explain those topics, please comment below and just type, please explain so topic, and I promise you I'm going to make a video on that topic. Once again, if you enjoy what I'm doing on this channel, please subscribe to this channel, share with your friends, turn or click on the bell notification so that you get notified anytime I post a new video on YouTube. Thank you. See you in my next video. I expect you to score over 320 in your UTME this year. Thank you. Bye for now.